mm, do upload or take a live class on capacitor, right? So my kids, uh, now I'm going to start 12th class chapter number 2. What is the chapter? Means we can say topic, that is capacitor. That is what, my dear, capacitor, right? So students, I can say for capacitor, what is the point here? What is capacitor? You can ask. You know, it's a because just now we finished here potential energy, that is self potential energy due to uh, HC, SC, HNC, also self potential energy due to SNC. So these all point beta are very very important, right? So we will try to understand what is the capacitance, right? So students, for capacitance kids, first we'll understand capacitance. This is what my kids capacitance, right? So ability to hold charge. So what is capacitance? Ability to hold charge at a ability to hold a charge at a given potential. What, student? Ability to given a charge, ability to hold charge at a given potential, at a given potential. So this is what, students, capacitance of capacitor. This is what, my dear, capacitance of a capacitor, right? So students, for this condition here, we can talk about capacitance of isolated capacitor. What, my dear? Capacitance of isolated capacitor. Students, you can take any types of capacitor, no need to worry. I said capacitance, capacitance of isolated capacitor. Okay, better, for this condition, I'm not giving you any size, right? Students, for this condition, I'm not giving what is the shape of the body. No, not at all. Just simply I'm telling the child what is the capacitance of isolated capacitor. Capacitance of what? Isolated capacitor. Let us suppose you can say, sir, you can take any shape of the body, any shape of the body, right? But there is one thing, students, I hope all of you remember here. If we will give a charge to a conductor, all charges will what? Resides on the surface of conductor. All charges, what, my dear? Resides on the surface of conductor. So let us suppose you can see V is the potential of this conducting surface. What is charge given by U? That is what? Q. That is what? Q. So here one things are very much clear, students. You can say, sir, potential is directly proportional to magnitude of charge. What, my dear? Potential is directly proportional to magnitude of charge, right? So students, one thing, sir, I wanted to tell you, beta, if we have anywhere in the physics or maths or chemistry as well, anywhere, students, if you are getting proportional sign here, so this is what, this is very much potential. We have to remove this proportional sign. We have to remove this proportional sign. So here my writing my kids, V is equals to C times of Q. Here C is what beta? We can say this is what proportional constants. C is what my dear? Proportional constants, right? So now students for this condition here, and C is the what? Basically is the what capacitance of the conductor means, v proportional to q. If you will remove proportional sign, then what you will get? V proportional to cq, where c is what proportional constants, but in reality what you can see, c is the capacitance of capacitor. What my dear? C is the capacitance of a capacitor. So you can write here for this condition, what is the c? What is c? C is equals to V by Q. What, my dear? C is equals to V by Q. So what is, I see there, what is the formula? Definition of capacitance: ability to hold charge at a given potential. Ability to hold charge at a given potential here. So C is what? You can say V by Q. Q is equals to beta. Q is equals to, you can say, V proportionals to Q here. So V is equals to what? You can say V proportionals to C, students. So this proportional not exactly C here. This is what proportional, you can say 1 by C. Then everything will be fine. So this is wrong, beta G. C you can write. C can write. This is what, students? Q by V. C can write what? Q by V. C is equals to what, students? Q by V. Right. So here students be there one things, anywhere if you are looking at any things, so you can tell those quantity depends on these things. Just let it be. Just think carefully. Student, is depends on charge. First questions. C is depends on potential. Reply me in chat box. Reply me in chat box. Students, anyone, anyone from all of you, anyone from all of you, answer me. C is depends on Q or C is depends on V. What is your answer? Anyone from all of you? Anyone from all of you? Okay, C is what? Q by V. Yes, no, sir, it's independent. Correct, student. C is beta literally look like C is equals to Q by V. It's right. But my kids, C never depends on charge as well as C never depends on potential. How? Have a look here because we remember everyone. What is a potential? Let us suppose you can take this is what we have a hollow conductor which is fully charged outer surface. As I said here in the property of conductor, for us maximum cases what we will get, that is what conductor here in a spherical shape. So here you can be done. If charge is q over here, so what is the potential on the surface of conductor? You can say simply, sir, this is what k q by r. You correct, my dear. V is equals to k q by r. You correct, beta. Okay, fine. So now students, this sphere I'll use over here. Just proof C never depends on charge and C never depends on what, my dear? My dear C, my dear student, C never depends on charge. C never depends on potential. Right. It's a definition, ability to hold a charge at a given potential. True, no doubt. But C never depends on charge as well as C never depends on potential. How? I'll prove. Now, students, you can say C is what? Remains Q. And what is a potential? You can write KQ by R. You can say QQ, kupach kupach. Q corpus corpus. So you can say C is equals to R and K is what beta? 1 by 4 pi epsilon naught. So C can write student 4 pi epsilon naught into R. You can write students C is equals to 4 pi epsilon naught into R. So what student? C never depends on charge. C never depends on potential. C depends on what? Dimension. What my kids? C depends on dimensions, right? So here I'm writing a points on which capacitance of capacitors depends, right? So this is what my dear, this is what my dear, it depends on student, it depends, it depends on its size, it depends on its size, shape, and the medium, and the medium in which you kept capacitor, in which you kept capacitor. So we remember shape, size, and medium. Shape, size, and medium. In this factor, capacitance of capacitor will depend, right? Okay, now bacha party. So have a look next here. Basic point bacha. First, I'll cover now students what you said. Actual definition of capacitor, kids. Tell me everyone. C is equals to Q by V. So just tell me everyone, what is SI unit of capacitor? SI unit of capacitor. Tell me everyone, what is the SI unit of charge? That is coulomb. Potential is what? Volt. So students, you can write here coulomb, coulomb per volt. Coulomb per volt, which is known as, my dear, farad, which is known as, my dear, farad. So we remember SI unit of capacitor is what? Coulomb per volt, or you can say farad, or you can say, my dear, farad, right? So what is the SI unit of capacitor? That is what? Farad. Okay, now a bit more interesting. What is a CGS unit? My dear, what is CGS unit? CGS unit of capacitance. This is SI unit of capacitance. Yes, it's capacitance. CGS unit of capacitance, which is what my kids say? State farad. This is what? Stat farad. Which is what, my dear? State farad. Stat farad, yeah. Right. Let's keep in mind. Okay. Capacitance belongs to quantity. Tell me, scalar vector. It it belongs to it belongs to quantity. It belongs to quantity scalar. It belongs to quantity scalar. It belongs to quantity scalar. Okay. Now after this year, we can just go through next topic. That is what, my dear? It's the introduction of capacitor, capacitance of parallel plate capacitance of parallel plate capacitor. Capacitance of, my dear, capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. Have a look, beta. Students, now we have, this is a condition here, you can understand like this. We have a two parallel plate capacitor. My dear, one is charged positively and another one is what? Charged negatively. Yes, beta. Now, one is positive charge and one is what, my dear? You can say negative charge. Now, students, you can say D is what? Separation between the plate. There is what? Separation between the plate. Positive charge beta, so you can say this is what? Charge positively. This is what you can say negatively. This is what the charge positively. This is what which I represented direction of electric field, which I represented, my dear, direction of electric field. High to low potential, high to low potential. You can also say what is the potential difference, which is V, which is V. But we wanted to find capacitance of parallel plate capacitor. So this is what you can say C is equals to, its formula there, charge volt per unit potential. So C is equals to Q by V. So Q beta forever constraints. What about V? Students, now I just taught last week. That is what relation between electric field and electric potential. So I said here V is equals to ED. I taught these all things. Potential difference in uniform electric field. I taught here. Try to be remind. So V is equals to ED beta. So I'll write over here V is equals to ED. Now beta, I'll find first electric field between the capacitor. Beta, you know what, my dear? Electric field due to infinite seat. What is? Tell me. Sigma by 2 epsilon naught. Right now, dear? Okay. But you can say, sir, we wanted to find what is electric field net. You correct, beta. Because here, due to positive charge, electric field radially outward, negative charge radially inward. So you can say, sir, I'll write sigma upon 2 epsilon naught due to one charge. Next, student, sigma upon 2 epsilon naught for another charge. So here, students, you can write sigma net, which is equals to sigma by beta, sigma by epsilon naught. So now onwards, we remember in your mind, for parallel plate capacitor, electric field between the capacitor, which is equals to sigma by epsilon naught. So C is equals to what? Tell me. This is charge Q, and we already be found sigma by epsilon naught into D. Okay, sigma is what here? Tell me. Sigma is what? I taught here these all things. Still, I'm writing here. Charge per unit area. Sigma is what, beta? Charge per unit area. So, beta, I'll use C is equals to beta. This one will push out. This is epsilon naught into Q. And sigma, students, charge per unit area into the, am I right, beta? Yes, you're right. Absolutely, sir. Q and Q, beta. Happy birthday. So what is it, beta? I can write here. Capacitance of capacitor. What you can write, my dear? Capacitance of capacitor. What is the capacitance of capacitor? Finally, you can write, my kids. This is what? C, which is equals to epsilon naught into A by D. Yes, my dear, this is the formula which we will use, for further, right? C is what? Epsilon naught into A by D. C is what? Epsilon naught into A by D, right, bacha? Okay, just beta, they asked beta this formula here. I can tell you when they asked these questions. Students, they directly asked at these questions in 2020. What's the year here? What is the year when they asked these questions? Directly? Yes. There is a question here. I can tell you very strong. They asked multiple times. Yes, I'm looking to tell you exactly ditto questions here, so that you will confident here. So they can ask also this much things. Because classes are I'm just arranging for your for more betterment. Yes, beta. 2024. Yes, beta ji. What is the year? 2024. So beta, we remember here. Right. Beta ji, 2024. They asked just application of this formula. So we remember here. They can ask anything. So don't I can say beta give up any points behalf of entrance. You have to do each and every numerical. You have to do each and every numerical. Right, beta? Okay. Come, boys and girls. I'll do here one numerical based on this only. I hope concept you cleared it. Says what? Capacitance of parallel plate capacitor epsilon naught into A by D. Right. Okay. Have a look at that next year. So this is what, my dear. This is what, my dear. Now, yeah, I'm going to solve questions JEE 2024. Beta JEE 2024. This is what? April attempt. This is what? April attempt. What's the question, kids? I'll tell you. Beta, this is the first capacitor. This separation is mentioned, kids. D by 3. Beta area, you can take. This is A by 3. For this first capacitor, you can write here C1. C1 is what? Epsilon naught into A by D. So what is A, Bachchaji? What is A by 3? And D is D beta, not D by 3. It's only D beta. My bad. Extremely sorry, beta Z. So this is what you can say epsilon naught into A by 3D. This is what you can say C1. This is what you can say C1. Okay, right. So students, something here for these questions. I can say next student. This is remains T and this is remains beta G. I can say This is the separation between the plate remains D, and this is area here. Again, you can take A by 3. Next, again, students, this is C, and this is D here. This is A beta D, and this is A by 3. So total plate area mentioned here, that is what A. That is what A. So this is what beta I found C1 here. You can directly found with Chaji, this is what C2. So right. So what about C2 student? You can say epsilon net into A by D beta. Formula remains same here. So this is epsilon net into A by 3, and D is what? D plus D beta. It's 2D here. Keep in your mind. This is 2D. So this is what? Epsilon net into A by 60. Now students, you can find C3 here. Beta, this is C1, this is C2, this is C3. So formula remains same beta for capacitance epsilon into A by D. Now students, this is epsilon naught A, this is remains A by 3. What is D? D plus D plus D, 3D here. This is what you can say student 3D. So you can write finally epsilon naught into A by 9D. Bacha, this point, this why I have taken this illustration, my kids, just because yeah, I can say for your sake of convenience, they can use this formula. But remaining part beta, which I didn't teach you those part. Basically, bacha, these all are what in parallel. These all are what students parallel here. So basically, they ask these questions. Find C equivalent. But I didn't teach you, just I'm giving you idea how can you do. But for parallel combinations here, you can use formula of series combination of resistor. But it's a parallel combination. Just I'm telling you for this question, just be remember. But I'll tell you later on, right? So beta be remember. So these all are what students? Parallel combinations, right? So here students, I'm going to tell you this. You can use the formula for what? Series combination of resistor. So students, here simply write C equivalent is equals to C1 plus C2 plus C3. So you can take beta epsilon naught into A by D. It's common. This is what? 1 by 3 plus 1 by 6 plus 1 by 9. Beta, take your LCM 369. 369 beta G. So 3 1 are 3, 3 2 are 3, 3 3 are 9. Yeah. 3 2 are 6, 3 are 18. This is what? 18. Beta, there is no change. Epsilon into A by D. 18 years. You can say this is what? 6 plus 3 plus 2. How much coming with you? No, 11 year. So C equivalent, you can write, my dear, C equivalent 11 time epsilon into A by 18 upon D vector. Right. So this is, my dear, answer of this question. But these questions I didn't complete it. I can see it wholly, completely. But just I use the formula here. I'll tell these all things, how parallel, how series. Just keep in your mind. Now, students, after this, yeah, just put the next heading. That is what, my kids. That is what, my kids. Energy stored in the parallel plate capacitor. Student, next topic. Energy stored in the parallel plate capacitor. Energy stored in the parallel plate capacitor. Energy stored in the parallel plate capacitor. But very, very important here, my dear. Very, very important. Okay. So to derive this result kits, I'll use same thing. Beta, this is parallel plate capacitor. This plate is positively charged. My dear, this plate is negatively charged. As usual, you can take beta, that is D is the separation student and V is the potential drop. This, these all things keep in your mind. Want to find energy, right? So here students, I'm going to use here one formula, that is energy density, which is equals to half epsilon naught E square. Energy density is what? Half epsilon naught E square. Half epsilon naught E square. So what is energy density, beta? This thing I taught recently in 11th class. Energy density, students, you can write energy per unit volume. Energy per unit volume, which is equals to beta half epsilon naught A square. Energy density is what, my dear? Energy per unit volume, which is equals to half epsilon naught E square. We don't want energy density, we wanted energy. So we can write, kids, energy is equals to half epsilon naught E square into volume. Here, beta, one things you can take A is the area of parallel plate, each capacitor. A is the area of parallel plate, each capacitor, right? So here we can write, students, energy is equals to half epsilon naught A square. Volume is what, kids? Area into length. Here you can write area into length. Okay, just now I proved previously what is electric field between the capacitor. I'll not prove again and again. That is sigma by epsilon naught. What, my kids? Sigma by epsilon naught. Okay, so I'll use bacha this result here. This is energy is equals to half epsilon net. What is E square? So we can say sigma square epsilon naught whole square into area into D. So we can say this is and this is cancel. So half of sigma square epsilon naught A into D. Sigma beta, just now I said here. Sigma is charge per unit area. So I'll use, my dear, half Q square A square Q square A square epsilon naught into A into D. You can see A and A copatch. So this is what, students, you can write further here. Beta Z half Q into D बच्चा जी epsilon naught into A epsilon naught into A. But I hope all of you remember, kids. Just now I proved here epsilon naught into A by D is what? C. C is what, students? Epsilon into A by D. C is what? Epsilon naught into A by D. Right. So students, I'll continue here, my kids. Yes. So energy is equals to, students, that is half of C into Q. Energy is what, my kids? Half of C into Q. Now here you can put Q is equals to CV. So also you can write half of CQ, half of CB square, and V is equals to Q by C. Because here, C what you can say? Q is equals to CB. Right now, so C can write near Q by V. So this is also correct near Q square by, tell me, because C is what? So you can see Q square by 2V. Correct near. C. First you put it CV square. So Q is equals to CV. So you can say half Q is equals to CV. Half C square V. Q is what? Q square by 2C near. Okay, there is some mistakes I can say. Hmm. This is, students, it's a Q square. So for here you can write these all things wrong. These all things wrong. Ignore kids. Okay, because what is energy we got? Q square by 2C. Energy is what? Tell me, beta. Q square by 2C, right? Or beta, you can put here Q is equals to CV. So again, you can say energy is equals to half CV square. Energy is equals to half CV square. So beta, be remember here these all points. Okay, beta, you can use your any of the number. Note, बच्चा जी, note. N-O-T, note. Beta will helpful. Right. This is what, my kids? Energy stored energy stored in the capacitor in form of electric field, in form of energy stored in the capacitor in form of electric field. What, my kids? In form of electric field, right? Then students, put the heating there. Here I'll not discuss RC circuit completely, right? Here just I'll give you idea about RC circuit. So we can put the heading introduction of RC circuit. Introduction of RC circuit. Right. Okay. Come it. So this is R and C. But I know in our means in the physics there are three circuit elements. Student, in the physics, there are three circuit element. What is the first one? My kid, first one is resistor, which is a part of current electricity. Student, second is what? Capacitor, which we will learn here. And third is what? Inductor, which we will learn in the chapter of EMI. Right. So what's the topic here? Introduction of RC circuit. Introduction of RC circuit. Right. Okay. So this is students. There is combination here, one R, one C. But I just understand here how this is. Students initially at what? I'm just telling here. T is equals to 0. This is what? T is equals to 0. Beta, there is resistor, and this resistor is what? Now I'm going to connect, means I'm connecting with uncharged capacitor. Keep in your mind, with uncharged capacitor. Beta, I can say R and C, both of the circuit element. I'm connecting with DC source. I'm connecting with DC source. Keep in mind, but a very interesting class here. Yes, my dear, very much interesting here. Okay, so you can say R is what? Resistor of, means R is what? Resistance of resistor. And C is what, student? C is capacitance of capacitor. Initially, beta, at T0, you can see this is what? V is the potential difference of the battery. Okay, now students, T0. Just now, beta, I can say resistor connected to capacitor. Resistor connected to capacitor. Okay. So student, for this condition, what is observed here? Students, entire this potential drop will what? You can say entire potential beta charge current means what? Charge current is what? You can see that there is a potential difference. So current will flow. So current means what? You can say charge. So now we can see charge on positive plate. Source of the charge is what? Negative plate of capacitor. How about simply you can write here. So this entire potential difference will what? I can say only potential difference. This V totally will exhaust by this resistor only. So you can see at T is equals to 0, current on resistor or current passes through the circuit. That is what? I is equals to V by R. I is equals to V by R. I know there is no potential drop on resistor. Entire potential drop, you can say this is 0 potential drop on resistor. Entire, what is the potential difference of battery which we connected in the circuit? Entire drop, what I can say, utilized by resistor only. So you can say I is equals to V by R. I is equals to V by R. Here again you can say, bacha, this is 0, this is 0, this is V, and this is V. No, beta, this is the way you will learn in current electricity how to take 0 and V. Bacha, anywhere in the circuit, this is your total choice. But you can see, just be careful. What is the direction of battery which you are using in the resistor, which you are using in the circuit? According to that terminal battery, you can take 0 and V. You can take 0 and V. Now, students, I'm telling you, time becomes T. Now, students, I'm telling you, time becomes T. Right. Students, once time becomes there, then what you can say, student, yeah, capacitor started charging little. Time, time 0, there is no charge on capacitor. If time becomes T, students, capacitor started charging little. Right. Once student capacitor started charging here, so you can say there is a potential drop across the capacitor. You can write there is a potential drop across the capacitor. You can write this is V. So what is the potential drop on the capacitor, my kids? V is equals to, you can say, this is remains R beta, this is C. So drop, potential drop on capacitor, which is Q by C, which is Q by C, right, students? Okay, now yeah, I wanted to write what is the value of I over here, because in the circuit current is again flowing I only. So what is I value over here? You can say I is equals now here. This V value got divided. Few amount of V potential drop on resistor. Same, this is the due to this potential here, we can write, already I have written potential drop on capacitor. So you can say I is equals to V minus Q by C upon R. So you can write with say finally here I is equals to CV minus Q by RC. I is equals to CV minus Q by RC. Right. I'm not going to. I'll use this derivation later on. Right. Student, this is you can say first part. This is the second part. Third part, beta. Let us say if time becomes infinite. If time becomes infinite, beta, for that conditions, what you can say, sir, capacitor becomes fully charged. Capacitor becomes fully charged. Once beta capacitor becomes fully charged, there is no value of current. And this stage is known as steady state. This state is known as, my dear, steady state. This stage is known as, my dear, steady state. This is C, this is R, and this is V. This is C, this is R, and this is V. So for this condition, students, you can write current will be at this condition here. There's no, I can say current drop on what? Resistor here. So for this condition, you can replace resistor because no, there is no value of current. There is no value of current if once capacitor will become fully charged here, right? So beta fourth diagram, I'll write beta later another phrase here. So beta, you can say if there is no value of current, capacitor becomes fully charged. Capacitor becomes fully charged. So what you can write beta for this condition here? This is the condition, students. You can show the circuit without resistor. So this is point, student. This is the V. You can say fully charged. So it's plus Q and it's, you can say minus Q, right? There is 0, 0 beta. This is V and this is V. So battery carried what charge from beta. These all things that you can answer how these all things happening. Simple beta. What you can see, battery carried charge from negative plate of capacitor because battery has to maintain potential difference equals to V. So battery carries beta negative charge. Battery carry charge from negative plate of capacitor. Battery has to maintain potential difference equals to V only, right? Note, battery is not a source of the charge. Battery is not a source of the charge. Keep in your mind. Battery is not a source of the charge, right? Okay. So further, students, what is the discussion here? I'll do these all points later on. There is few numerical there which we can do from here directly. Discussion. Discussion after steady state. Discussion after steady. Yes, beta. Interesting here. after steady state. So what you can see, students? You can see now, sir, capacitor will become fully charged. Capacitor will become fully charged. You correct, Betaji. Right. So charge flowing into the circuit, how much here? Q is equals to CV. So what is the charge accumulation on positive plate of capacitor? Because this is connected to positive terminal of battery. So this is what you can say plus CV. This is what you can say, my dear, minus. You can say, my dear, this is what minus CV. But one thing I want to tell you here, if any charge flowing through the circuit, what is the potential energy? What is the potential energy? You can use Ramban. You can use Ramban. U which is equals to QV. U which is equals to QV. But keep in your mind, right? So this is what you can say potential energy of battery. Student, potential energy of battery, which is equals to QV, which is equals to QV. Now, beta, I wanted to write work done by battery. Work done by battery. That is what, yeah, I said the use RAM formula. This is what QV, and Q is what? So you can say what's a part is CV square. So work done by battery is what? CV square. Work done by battery is what? CV square. Okay. So what about energy stored in the capacitor? Student, what about energy stored in the capacitor, which is equals to half CV square? Energy stored in the capacitor, which is equals to, my kids, half CV square. Half CV square, right? So what about heat here for this pattern of questions? So heat beta formula here, keep in your mind. Heat is equals to, students, work done by battery. Its formula here, beta very very useful. Work done by battery minus energy final of capacitor minus energy initial of capacitor. My dear, superb important. My dear, superb important. So what is formula of heat? You can say from here, work done by battery, how much? CV square. Energy final, initial energy zero na beta. Everyone, initially there is no charge. So what about initial energy of capacitor? Zero only. This is what you can say, but charge zero only here. So heat is equals to what you can write? What is the value of heat you can write? What is the value of heat you can write? What is the value of heat you can write? That is what heat is equals to half CV square. This is what, student? So you know what is work done by battery? CV square. Yeah. Energy is stored CV square. So we have the remaining, because remaining half CV square what will convert in terms of heat. Half CV square converted in terms of heat. Right. It are very much interesting here. Right. So now, student, this we will go through a practice of the questions. Yes, my dear. We'll go through practice of the questions. But a very good question, sir. Very good question, student. Not a good question. Very good question here. Will do. So this is the first question, kids. This is the first question, kids. What is the question here? Let us suppose initially I'm considering over here. There is a capacitor, capacitance C. Across this capacitor, there is a V volt battery. Listen carefully. This is the first part of the questions. Beta, if I'll connect same capacitor, capacitance C, across 2-volt battery, find heat. My dear, I'll repeat here these all things. Beta, this is I can see initial stage of capacitor. Same capacitor here. Connecting here across 2-volt battery. Find heat. Find heat. Find heat. Right. So beta, we'll go through formula of heat here. This beta, just we'll go through solution of the questions. See, bacha. This is what capacitor C and potential V here. What's the charge over here? You can say this is C. You can say this is CB. And what charge over here? This is what you can say minus CB. Remember, yeah, simply I used formula. Okay, now beta, we talk. If this same capacitor connected to 2-volt battery, then what will happen? See, bacha. This is C beta. This is C. This is 2-volt battery. So this is connected to negative terminal here. So we can say this is minus 2CV. And this is plus 2CV. This is what my kids plus 2CV. Simply, but just be careful here how this part is very crucial. My dear, this part is very crucial. Student, see carefully. I can say left plate of capacitor, there is what charge CV. And here left plate of capacitor, left plate of capacitor charge is minus 2 CV. So we are pretty sure, sir, charge is coming out from here. Charge is coming out from here. Bacha, again, yeah, trick. How much charge coming? Again, I'm giving you trick. Bacha, if your final charge is what decreases, then you can do charge flow. Charge flow is equals to, my dear, initial charge minus initial charge minus final charge. Students, you can write initial charge minus final charge. So what is the initial charge beta? This is what CV. Final beta G minus 2CV. Minus 2CV. So this is what you can say 3CV. So beta charge coming out here. How much? 3CV. And what we have to find heat? What we have to find heat? So what is now, students? I'm using formula of heat, which is equals to work done by battery minus energy final up stored in the capacitor minus, yeah, energy initially stored in the capacitor. So here, student, work done by battery, how much? What is work done by 3? CV square. So this is what? 3 CV. Q into V near. What is work done by battery? Q into V. So what is Q? 3 CV into 2V. So this is 6 CV square. 6 CV square. Okay. Now, what is energy final? Energy final, what I can calculate here only here. This is energy final, student. You can say half CV square. So half bacha and C remains C. And what is V over here? 2V. 2V whole square. So you can say student 4CV square by 2. And this is 2CV square. This is what my kids? 2CV square. So we can write beta here 2CV square. What is the energy initial here? 0.5 CV square. 0.5 CV square. So 2 minus 0.5, 1.5. 6 minus 1.5, 4.5. So what is your answer? 4.5 CV square. So my dear, this is all about today class. It's too late here. As I committed here, but there is a meaning of commitment. So she said, so but I said, yes, I'll upload a lecture. So today lecture, my dear, only I can say 1 hour only. But by tomorrow, means tomorrow, beta, if I'll get free, definitely I'll continue from here onwards. So stay at home, beta, be happy. Uh, be regular here. Is there any problem? Just write your question in comment box. If I'll see and come back to you. My dear, this is the format of the question. Yes, beta. This is the format of questions are very much confusing. Very much confusing. Usually, beta, this part. Charge flow, that is what? Initial charge minus final charge. So what is initial charge here? This is CV. Final charge minus 2 CV, so minus minus plus. This is what? 3 CV. Work done by battery here. This is what? Q into V. So Q how much? 3 CV. And V is what? V bacha party. So what you can say? This is what? 3 to the 6 CV square. Energy final बचा half of CB square, half बचा C, and what is V? 2V here. 2 beta kupach, you can say 2 CB square. So energy final 2 CB square, and energy initial you can write na beta. That is what? Half CB square. So you can say energy initial is equals to 0.5 CB square. 0.5 CV square. So my dear, this is all about today class. Now I'm going to stop live class.